Hey everybody, this is Larry. This is day 20th, if it loads, of the Leetcode Daily Challenge. Hit the like button, the subscribe button, join me on Discord. Let me know what you think about today's forum. Not sure why my computer is slow right now, or my internet is slow anyway. Oh wow, now we're having a hard problem. We've been having easy problems all week. Now we get a little bit of a tricky one. Today I was doing more rehab stuff. I was trying to do squats. This is a workout update, by the way, for you those who are new to the daily videos, where I talk about my workout just to kind of well, in a way we're all struggling together, right? And I'm struggling right now with a shoulder injury that I got just last week snowboarding, and today I was hoping to do squats, and my legs are okay, but if you know how squats work. If you don't, well, I guess I'm sure you have to like hold the bar like behind your back, and then you go down, right, like this kind of. I mean, it's not quite perfect because I'm actually sitting in a chair, so But my point is that you have to put your shoulder or your arm back, but also with that shoulder flexibility of being able to get there. And today, even just doing this is very painful. Not like a very nagging pain, like maybe not like a painful, but just like I don't know, a tough position to hold right now. And I was trying to do it today, and I just didn't have confidence in it, because it was just like in a lot of pain, right? So I just did a lot of shoulder mobility exercises as a result, because I did end up doing squats, but not as heavy because I just didn't trust it as a heavy thing, like to hold up the bar in a good place. So I just kind of did what is usually my warm up, so like about my body weight, and just did like a couple of sets, just to kind of keep my legs, reminding them that hey, you have some muscles there. Don't lose it too quickly, But yeah, but that's basically my workout thing, and hopefully I'll heal so that I could go snowboarding again. I mean, I could probably go without healing, but I don't know if I should. In any case, let's take a look at today's problem. We have a hard problem, finally back. It is 761, special binary string. Special binary strings are binary strings with the following two properties. Number of zeros is equal to the number of ones. Every prefix of the binary string has at least as many ones as zeros. You're given a special binary string S. A move consists of choosing two consecutive non-empty special substring of S and swapping them. Okay? Okay, so we could do as many moves as possible. Is that my understanding? And you want to get the largest resultant string possible. Two strings are substrings, not subcharacters. Or not characters, rather. Okay, two strings are consecutive. I mean, I guess consecutive makes sense. Okay, so in this case, we swap one. What do we swap? We swap 1 0 and 1 1 0 0, and we can only swap special substrings. I don't like that they bold them here and then they don't bold them here, because like special is like special is an English word, right, and not a keyword by itself, and you can just say things are special. I don't know, right? Like, so it's hard to kind of I don't know, especially if you're reading fast like me. Sometimes it's hard to kind of like pick it out that like, hey, we're using special as a keyword, not as an English word or whatever, right? In any case, okay. So we need these things, and then we kind of just want to maximize, right? Is that the idea? Okay. The first thing to look at, of course, is just the constraints, and just to make sure. Honestly, I didn't expect this to be 50 necessarily. I was mostly looking to see if it is 1,000 to it either is 1,000 ish, which means that there may be an n squared solution, or like 10 to the fifth or something like that, where there's an n log n or something. But n is equal to 50 actually. I mean, I right now I'm talking a lot, but just to be clear, I have no idea how to solve this yet, right? I mean, we'll work through it together. This is why we have a live recording. But so I thought maybe, like, without looking at the constraints, I thought maybe there's some kind of playful, greedy solution, right? But seeing that n is equal to 50 means that, well, it's a little bit surprising, but that means that now we're looking for like n to the third or n to the fourth even kind of solutions, right? and I'm trying to think whether the greedy solutions hold. So and the thing that we can do now is kind of just make observations to see what we can, even just like playing around with the texture of this problem in general, right? And the first thing that I would say is that you cannot kind of combine moves. I don't know if that's the right way to phrase it, but what I mean by that is that you cannot say, like this is example one. I mean, of course, you cannot do something like move this. I mean, you can't do it anyway, but my point is that you cannot move this, like, try and ask you on it. Maybe I should just, maybe I'll pick up the drawing pad. But you cannot move like these two to here, to here, and then with the goal that, I don't know, maybe you would have more zeros, and if you have changed that, if you're able to change that, maybe you could have done something like, you know, because then now, in theory, you made it so that a future move is better, because then now you can move 3 forward, maybe, right? I'm not saying that, you know, I'm not saying necessarily that, I don't even know if this helps at all, but this is just an observation. And sometimes you just make a lot of observations that sometimes help, sometimes doesn't. But what I try to get at here, for me anyway, because I still don't know how to solve this, is that, and I'm not quite sure about this yet, right? But it has the texture of something that, like like, I want to say maybe is somewhat greedy. It doesn't have to be a globally, or a local greedy thing may not lead to a global greedy thing, but there is some sort of a playful greedy component, because you're not, or maybe not, that's not quite the right way to think about it. Or there's this idea that, like, well, one move, like if you think about the moves that you can make, right? Maybe you can think about it as like a higher order move that I want to think about, meaning that, okay, well, if you do these two things, you could consider it like one big move that is more optimal than doing these two moves, right? But because of this property or this idea, well, that's not the case. Every move should be able to stand by itself. Maybe, right? That's the idea that I'm throwing out, right? Because these things are hard. And honestly, if it is some sort of like greedy-ish idea, it is hard. Greedy is definitely one of the things that I'm weakest at, because it's like, if you tell me the solution, I could probably prove it, but sometimes that's not enough, right? Or that's not enough to come up with the solution, right? You have to come up with the solution to be able to kind of work on proving it, right? In any case, so that's kind of what I'm my first but yeah, I'm gonna get a water real quick because I feel like I'm gonna talk a lot in this video. Yeah, all right. Oh, I forgot to get cereal. Okay. Actually going to do some like iced tea thing. But Oh yeah, I forgot to say this, was it yesterday? But yesterday, or well, yesterday's video, I don't know, the other days are kind of mixed up together. But Ramadan Mubarak, I feel like Barak, I don't know. So my apologies, I'm trying, obviously. But yeah, just, you know, to my fans out there, for, you know, hope y'all are staying strong in the time of fast. I did do okay, maybe I gotta make this like an intro at another time, but because I do have a fasting thing that I do, but maybe we should get back to the problem. Okay, sorry, let me drink this more quick. Okay. Yeah. So I think so. Anyway, getting back to this, none of these happening because the way that you would get better is by kind of combining ones or combining zeros, one of those. But as a result, it's almost like there's a delimiter here, right? Like you can only swap. Oh, and they have to be adjacent. I forgot about this actually. So I messed up already anyway. But I don't know why they say consecutive instead of adjacent, because it is a string. But I mean, I guess they're probably mostly the same, but it feels like a little bit of it impreciseness. But in any case, yeah, so definitely not that, right? But then the question is, yeah, and yeah, then because of this adjacency-ness, this is even more true, right? Because after a swap, after any swap, right, of two adjacent elements or two special adjacent elements, right? If you look at these two and these four, it means that if you swap them, well, this one's then by definition, the thing that comes after this will be a one, right? So no matter what, you have like one or whatever, right? And what I mean by that is that because, and this is the old special string that was in the back, but because the new special string, wait, did I misread this problem? I think I did. I may be just saying a lot of different things because I got confused for this one. Well, I think I got confused by the examples. Because it doesn't have to be, right? Wait. Let me. I think I didn't read this part correctly. Because I think I read this as saying that it has to be like something like this. Like it has to be all ones in the beginning and all zeros at the end. But this is not quite true. This is a hard one to even just read apparently. But every prefix of the binary tree has at least as many ones as zeros. So that means that the first one has to, I mean, this is still kind of true, but I don't know if, I mean, this part where one has to be the next string is kind of true, but I don't know how true, right? Because then now you can have one, right? You have 1 0, then that prefix is good, but that means that you always have another one afterwards. So this is the most whatever string that you can do, right? Like a evenness. But that means that maybe what I said here is not true about combining moves anymore, right? Now I have to think about this again. Man, this is annoying. Yeah. I mean, the first character has to be a 1. Well, yeah, I think the next move in either case, whether would be to play around with some other ideas, right? Let's say we have something like this. This is special, but also, so that means like substrings of these things are also special, right? I think the thing that I'm trying to find is like one idea, one invariant that allows us to kind of, you know, because another idea that I'm thinking of just right now is maybe like a divide and conquer thing. But if we want to do a divide and conquer thing, then we have to, I don't know, we have to figure out a little bit better, right? Maybe we can just still do a divide and conquer, but sometimes, but you need, I guess we can do divide and conquer actually. No, that doesn't make sense. Because you could, or you can't do divide and conquer because you can swap like something up to the end, right? Like if you have to do at the end of this, for example, then you just move this back. I mean, you could also just move all of these back because this is all special. And you can move this back. So, okay. So one thing about the special binary, I think this is the key part that I was, no, that's not true. But one thing that is about the special binary is that a big, how do I say it? Like 2 consecutive special binary is itself a special binary, right? Because by definition of this prefix thing. So what does that mean? That means that in a greedy way, we can construct all the special binary strings and then solve for them recursively. Almost like like a divide and conquer, but maybe not like the split in half divide and conquer. But I think not every prefix per se, but if you delimit them, and then as a result, because a special binary string, a big one, or I wanted to say something like a special binary string, it makes up is made out of smaller special binary strings, but that's not quite precise. What I want to say is, I guess, consecutive special binary strings do, if they're swappable, means that if you combine them, they're one big special binary string, and you could kind of like keep on concatenating them, right? And then as a result, and if they're not, then you just can't do it. But as a result of that property, then you can just solve for that chunk, right? And if you could solve for that chunk, you kind of almost do it recursively, right? Actually, I don't know about recursively, but because maybe it's not recursively in the sense that it's recursive, but you just solve for a chunk at a chunk, and then you concatenate them back together, right? And it's almost like you sort the stuff in between, or like you have a chunk, and then now you sort the stuff in between, and then you're good, right? I think that's right. So you want to find the biggest special binary string chunks, and then in the beginning, and then sort within those chunks, and then yeah. Okay, let's see if that would work. I don't know. I mean, I don't know that I'm explaining it well, or that it's precise enough. But I think those are the ideas that I'm thinking of right now, right? Okay, so let's play around, right? The tricky thing is that, like, you could have like someone like this. So then now you have to figure out like where to begin the first chunk, right? Because I guess it always just begins with ones. Because if you have a 1, then you almost always have a special chunk, or possible beginning of a chunk. It's annoying though. Okay. Because in this case, you actually want it to end here, but you can also have another case where, like, you have something like this, and then a bunch of other stuff, whatever. Then now you actually only want this thing to be a thing. And technically speaking, it would actually combine all this as part of the biggest chunk, right? So then we actually want, yeah. And the way to kind of write this is that because we want to recognize this part without this part, right? So that means that, or I mean, we can recognize this part, but we just have to figure out how to get rid of it, right? This is kind of annoying. I mean, it's definitely annoying. but I also don't, I think the thing that I'm more, which is why I'm like, I wouldn't say I'm procrastinating. The implementation is probably okay, but I'm just like trying to think through all the edge cases and kind of getting this part correct. That's one. And then 2 is, given I know how to implement it, I still not 100% confident that the algorithm is correct. But given that n is 50, we have a lot of leeway to do crazy things. So so we can play around, right? Maybe I could just use group by, right? Yeah, maybe I could just use group by, so we can maybe validate quicker. Xt in group by of S, right? G is for groups, right? let's make sure that is what we want. Oh, wait, what? Oh, yeah. Sometimes I forget. You have to convert it to a list because it's an iterator. And it's not like an iterator, but I guess it is an iterator. But anyway, right, 2 1s, 1 0. Okay, right? So then now, yeah, if the first number is a 0, we just kind of ignore it, right? But we have to kind of, if the first number is 0, we have to make sure we return it back. Right, so it's a little bit annoying. Okay, so then now maybe we have answers equal to this, right, for now. And then if, I don't know, the first element of this is equal to 0, then answer dot append gx of right, just like get rid of deleting zeros. Okay, right. All right, let's put a test case here. I just use the same one except for we have a 0 in the beginning. Oh, SS2. Oh, huh. Actually, I missed. I mean, I did. As honestly, when I was typing in, I'm like, wait, I think you're given one. But then I kind of was like, yeah, well, I might as well finish typing it. So then now this case doesn't even apply, and the entire thing. Okay, let me rethink this then, right? What does that mean? No, okay, no, I think that's fine. But what it means is that, okay, this entire thing is a whatever, right? Then now that means that, no, and also I think I'm wrong, honestly. In that, okay, for example, well, for example, maybe this is a special string, right? But then now you could have and maybe it is divide and conquer in that way, because now this is also a special string, right? Because we have one prefix, but then it does not compose. What I said was wrong, right? I just noticed when I was writing it anyway. Because I mean, it is wrong, but as a result, I think I see, yeah. Right. Maybe this is not necessary. I mean, well, I mean, because the way this is wrong anyway. But the reason is being that, and I don't know if I'm describing right, because I'm still kind of putting it together in my head, to be frank. But basically, you have this thing, right? And then now you wrap this thing. That means that this string is not composable of just smaller special binary strings, right? So I was wrong about that, because my earlier posture. Well, I mean, it is true that the concatenation of special binary string, and that's actually technically I was right, but when I converted it to be more precise, because the other thing would have been wrong. Because recall that I was saying that if you concatenate special binary strings, if you concatenate special binary strings, if you concatenate special binary strings, it does become a special binary string. But the first thing that I said was that a special binary string is consist of smaller binary strings, which I was like, wait, that's not quite precise. And this is the reason why. Because, yeah. I think now I see an idea though, because it is a special binary string to begin with, because then now we can do a divide and conquer thing. Well, is that called divide and conquer? I don't even remember anymore. So much names. But and I'm not gonna go over dynamic programming for this one because I don't know that this is correct, honestly. So I don't want to like spend time to be like, oh, let's go over dynamic programming, and then it turns out that this doesn't require it. I'm just wrong. So I have to play around with this a little bit more first. I think this is right, but I am uncertain about certain details. So yeah, but here maybe I just have a left-right dynamic programming, right, of getting the best answer from the left and right, and then here we can just return f of 0 and -1, right, inclusive, left to right inclusive, right. And then there are some ideas that we can play with, right. which is that yeah, if left is greater than right, then we just return 0 because there's just no character, which is fine, right? That would be my base case. There are a couple of ideas that I have. I don't know if they're exhaustive enough, which is the case of dynamic programming, is that you have to account for all the cases. But one thing that I might have is that, well, I think s of left has to be equal to 1, right? Because if it's 0 prefix, then we don't have a binary string anymore, right? So I come in here. This has to be a prefix of 1. Otherwise, we do not have a special binary string as an input, and we are crazy or something. I don't know. We're probably crazy anyway, to be honest, whether this is a special binary string or not. But we'll just have this as an assert. And then now, because we know that s of left is equal to 1, we can make one move that I can think about is just removing this thing at the end, right? And you would want to anyway, possibly, maybe. Oh, actually, no, this is wrong, but it's just that, well, we should not assert. Well, you could assert depending how you want to write it, but you can imagine like another case like this, or even just something as similar like this. You have a 1 and a 0, so I would attempt to remove the 1 and a 0 to go to O1, which is obviously not a special binary string. So we will, well, we would say no, right? So yeah, so maybe we write in this case, instead, if s of left is equal to 0, then we just return negative infinity because it is not possible. Or like we make it not possible, right? Okay, so we don't assert anymore. Okay, I mean, I'll leave the comment up there. Maybe we should fix the comment, but I think it's mostly still accurate-ish of, so we are crazy after all. Okay, so then now, that means that s of left is equal to 1, right? So this is the invariant for in this part. Then now, if s of right is equal to 0, and I think this has to be, because if you have a 1 as a suffix, then by definition, you have more whatever, right? So, so maybe I put it in there, right? And s of, well, it's an or, right? This is the same idea, right? Is that if we have a, if the last character is a 1, and that means that by pigeonhole, because if this chunk, that means that this substring has, we call that this substring has a has the same number of 1s and 0s, right? So if the last character is a 1, that means that the rest of the characters have whatever the half is minus 1 as the number of 1s. With so you have half of the string is 0, half of the string minus 1 character is 1s, so you have more 0s than 1s in this prefix of the substring, and therefore it is not special. So you cannot, yeah. I don't know if this is good enough, to be honest. This is a crazy one, or maybe just crazy for me. Yeah, because I do want to, because I think this is a case that we have to do, and we could kind of do it like recursively. Maybe that is exhaustive enough, right? So otherwise, one case would be f of left plus 1, right, minus 1, right? So whatever you get for that substring, and we'll just use the actual number instead of, because the biggest number is going to be the lexicographic. I didn't say that when I did the negative infinity and 0, but I'll say it now, is that the lexicographically largest string is just the largest binary string, and because n is equal to 50, you could store it in a long or 64-bit int, signed or unsigned, right? So, but that means that we're looking at here, we convert the middle chunk, which will be greedy, or not greedy, but you know, in a dynamic programming way, it'll be optimal for that sub answer. Then it's just this answer times 2 because you have a shift to the thing, right? So it's just going to be this times 2, right? And then, but this doesn't include any swaps. It just takes off at the left and the right, right? So then now we have to figure how to figure out swaps, right? Otherwise, no. I mean, I think we probably should pre-process some of this in either case. Right, but the problem is that it's not even just that, right? I don't know. I mean, I'm trying to figure out what's the best way to do like a DP idea of exhaustive, right? Because the problem is that, and maybe maybe it's just like adding a for loop, and I'm just being a little bit, because n is 50 as we said. Because the idea here is that, you know, if you have something like, I think something like this, you actually want to take this entire thing and then put this in the front. So almost like, yeah, so maybe we do want a divide and conquer idea. Maybe that is just the way to do it, right? Like well, I mean, we do want to divide and conquer, but we have to, and then sort on the chunks. The reason why I'm saying like this is because here we could obviously just sort one chunk, but there may be substring in which, like, there may be like, I don't know, let's just say another thing here, right? For example, like this would be a thing, but maybe, you know, you have to compare them in a good way, and then you have to recursive on here for whatever reason, because in this case, well, I mean, you know, you could probably combine it in a more like this is the thing, and then but to kind of optimize for this, you don't just sort, so you get the answer for, oh, so you get the answer for this chunk and then this chunk and then sort it, right? But we have to figure out how to like split it into these different chunks of, right? So here maybe we would split it like this, right? 1 0 0 1 1. I guess maybe it is just, maybe greedy works. I'm trying to think whether greedy works in sense of the greedy chunk setup, if that makes sense. Meaning that we can just go as far as we can, starting from the first string, and then here is a chunk, and then we just kind of recurse on that, and then now that we recurse all these things, then we can just sort them out. And here, of course, you would recursively, you know, convert this into something like this, right? And this, which, you know, you remove the 1 and the zeros like we do recursively, and then now you also do the same thing of breaking it into chunks and then sort them, right? I'm missing a 1, but you get the idea anyway. And then now you move this to the front, right? And of course, at its core, then each of these numbers is defined by just the number of 1. So you can be more like compact if you want, but I don't think that's necessary, right? So if we go to swaps in a greedy way, question mark, question mark. So let's go, let's try it. I mean, I don't know if this is right, but feels right. I don't know. It feels right. Feels right enough that maybe I'll be missing a case. It may not be exhaustive, but I think this is more correct, right? So okay. So here we go. 1 0 0, right? So for I in range from left to right inclusive, I think we defined them to be inclusive, right? Okay, so then now, if current, or if, what's it called, S of I is equal to 1, current increment by 1, else current 1. If this is negative, then there's something really wrong, I think. Can it be negative with this being true? I don't know, actually. I just do assert. I'm curious whether this is true. But in any case, if current is equal to 0, then we chunk it off, right? Yeah, so maybe call it chunks. And then here maybe we have previous is equal to left, right? Or maybe start. Let's go start, right? So this is there, right? Then chunks dot append start I as a chunk, and then we now set start is equal to, well, I minus 1. No, it includes this I. So then this start will be I plus 1, right? That's the next chunk, something like that. And then now we can write, what we want is like a chunks.sort kind of thing, right? Yeah. I'm just trying to think about all the data structure I need right now, right? But basically, you have something like for left, right in chunks, or maybe I should not reuse left, right. We should C left, chunk right. We go F of C left, C right, right? But now, yeah, maybe like R is equal to the result, as in is the best result, right? Kind of. Actually, maybe I could even just put the recursion here in the chunks. I don't really need it this way. So then we have start right, and then F of start I, right? Yeah. So okay, so that's fine. And then now chunks will, well, actually, we do want to sort by this number. So we will put it in the beginning, so that we can now then chunks dot sort kind of reverse is equal to true. Maybe that's not quite precise either, because I guess it doesn't matter if they're the same, because I was thinking about tiebreaker. I kind of want in a very like just naturalistic way. You want the earlier start to be earlier, but I guess it doesn't really matter, because in that case, if this y is the same, it doesn't actually matter what the start and end is. What I actually want, maybe I don't even care about the start and I. Now that what I actually want is just the number of digits. That's why I kind of kept it. So I could maybe I plus 1 for the number of digits. And you can actually get it from the results, because it goes to the number of 1 bit times 2. But you know, it's fine. Okay, so then now that we have that, and then now we can construct the answer, right? Yeah, I mean, that's it really, right? So let's just say R is equal to 0 for what's it called? X is lazy, but okay, fine. In chunks, we have R. Yeah, with R we shift by L, and then R added by X. I think that's it, right? And then now we, I mean, yeah, okay, maybe I'll just keep it this way, just because makes it easier to read. And that's really the idea. Hopefully, this may be wrong. Well, it's not wrong, but it's just that this never happens, I think, or not happen enough, because if left and because you have, oh yeah, because if you only have one chunk. Well, I mean, it's good that this is, or at least hasn't been an issue. But I think if you have one chunk, then it may recursive. It may call recursively in a bad way. So we have to, okay. So we might have to, well, okay. So I guess if it's only one chunk, then I is equal to, right. Well, I don't want double negative. So want something like this. That means that there's only one chunk. Where do I put? Well, we just don't calculate, I think. Do we just sort all the bits? No, you can't, because you well, it's just one big. No. Yeah, if it's one chunk, then no mass, right? So we can maybe just do the actual number, right? So we needed something like this anyway. I don't know how I'm missing that, because it's a base case. Oh, S. Oops. Then the number of digits. I don't know the number of digits. I mean, I don't think that matters now anymore. Okay. Oh, I forgot to convert it back to binary. How do I write that again? I just think just this, right? Alright, I mean, it's good that this is. Oh, I guess that's actually not a great case. I mean, I have an extra 0 for some reason, but structurally it looks okay, right? Maybe? I don't know. Why do I have an extra 0? This times 2, right? Because okay, let's walk it through, right? So we have. I mean, this may be just some silliness, which is fine. I think. Well, actually, I don't know. It does sort this substring, but I don't know why there's an extra 0. I think I just did the math wrong. This is just wrong anyway, right? Because I forgot the 1. So I think this is well, this is one chunk, right? But anyway, this is wrong because I just forgot the 1, right? So this is actually going to be this plus 1 shifted by right plus left plus 1 or something, or right minus left plus 1, right? Something like that. I don't know how that would. I mean, that shouldn't fix this anyway, but so this should return 0. Did I? Oh, right. Because we minus the 0, so this should be, yeah, okay. I forgot that we minus the 0, so now it should be good. Is this, I don't, do we have an extra 1? Alright, what is this recursion? Let's see. We have this. So the first recursion would be here. And so this return, and then now we'll do, right? Which it is kind of doing, but then I don't know why I have an extra 1. Right? Is it this part? No, I mean, this part seems okay. It's just the chunks. Well, maybe this math is wrong. But I don't know how it would have an extra 1. Okay, let's just print it out, right? So we have print left, right, binary of best, right? It's easy to just look at it. So from 1 to 2, okay, you have 110, 1 to 6. Huh, how do you have 1 to 2? Like, how do you split it up this way? Oh, this is a substring, then 1. But this should also be a chunk, right? Oh, this is wrong. This is if, okay, I'm just being dumb. If this is equal to left and this, so there's only one chunk, not the, because what's happening is that this is the last chunk, but we don't want that. Okay, okay, so that is just a, I guess I was just being lazy. I don't, no, I mean, I was kind of a little honed in on this part, so I forgot about there's only one chunk. So the idea is right, kind of, mostly, but I just kind of missed thing. Okay. So yeah, let's because n is equal to 50, you don't really have to worry about the complexity as much. But okay, I mean, it is what it is. I don't know if this would give us the right answer if without it. Well, how does that even happen, actually? I wish there's like an assert and print thing. I guess you could write your own. How is this right answer? If you have negative. If you have negative, then what happens? Like, that just doesn't feel right. I guess at some point it will just have negative infinity, so maybe that would be fine. I'll submit it again, but I mean, it definitely means that there's a misunderstanding. So okay, so we get it wrong anyway. But let's go back to 3. I think because why I have an assertion here is because of the invariant, and if the invariant is wrong, then there is some other funky things going on. Right, so here maybe we print so 1/6. What's 1/6? So 110. That's probably. Whew. All right, 110 is probably just an entire string. All right, so then why 110? Why is it never 0? Oh, because the recursion always just go kind of because I guess this is the first recursion, so we always do it first. Okay, fine. 1/6. 1, 2, 3, 4, 5, 6. How does the current is equal to negative? Am I doing it well? 1, 2, 3, 4, 5, 6. But no, I mean, huh? Why would this be negative? It's just 2, 1, 2, 1, 0, right? Huh? Maybe I have to put it here. It is what it is. Oh, it is part of the 110, not 1/6. So 1/6 was good. Oh, because it's part of the recursion. Okay, I'm just being dumb. Okay, 110. So this is this string. But that should also still not be true, right? Or am I confused? Because okay, let's just start the whole thing. We have 110. So presumably this is 110. I didn't really count. 5, 5. I mean that's right. No, that's 9. But I think 1, 2. Wait. No, it's 5, 5. So 110, and then 7, right? So 1, 1, 2. Oh yeah, definitely. Huh. I see. I mean, I guess that actually understands, because we should not be removing this is kind of the point of why this doesn't work. But and then now as a result, this returns negative infinity because this is not a routed substring, right? Or sub whatever. Okay, so here, if current is less than 0, we just return best because there's no other. It's just not a substring or not a special string or whatever it's called, right? But we still have a wrong answer, I think, even with that, right? So we'll see. And this is actually a more unfortunate thing, because this looks like in terms of correctness, it is like it's not a bad implementation, because in terms of rows it's probably correct, but it's just not giving you the ideal answer, right? And why not? Maybe I was wrong with what I said. So yeah, so here you would match with this. No, or at least it wouldn't give you the best answer, so that's not quite it, right? That's interesting. Because I was thinking that like the sub chunks would, and then merging them would give you the best answer, but maybe that's not true. Because maybe there is this like thing where you have to do more than that, and that is probably going to be the issue. How do I even think about it? Oops. Okay, how do I even think about it? Well, I guess we can at the very least print left, right, binary of best, right? Let's remove the other one just to remove some noise. So we know that this one is wrong. And maybe this is because of this. Like this should be moved even more. But why would that not be part of the 029 thing? Because here, it looks like there's some like thing where this is a chunk and then this is a chunk maybe, and it doesn't get sorted or something. I don't know. Are we not exhaustive enough? I guess is part of the thing. Because 0 to 29 or 20 to 29. I don't know why I said it like that, but. And then this gets sorted in, where's the... Something is fused wrong. Oh, I guess maybe there's just a lot of... No, I don't... Huh. I mean, obviously it's just wrong, but... I'm trying to figure out what the chord tree is. Let's see, with the 29, it breaks it down to like, I don't know, 8 to 19 maybe? 8 to 19, 0 to 7, 8 to 19, and then 20 to 29. Did I sort things? Oh, this is wrong. Well, it's not wrong, but I am just dumb. Because yeah, I'm okay. Because I was thinking about these things being one level deep, so I was sorting them by just a number. But then here, the sorting is wrong because it could be something like, you know, you could have 1, 2, 3, 4, 5, but then it's comparing something like this. Well, this is the bigger number, right? But this is the what we want. So I was just trying to be lazy. I think that's all. Okay. So we just have to do right. Yeah, I mean it's just string, right? Yeah, binary x, and then still reverse is equal to true actually because we want the biggest one. Oh, tuple cannot. X is going to be just the first number or the first component. There you go. So my idea was right, but my idea was right as long as you change it so that it is right. But okay. Let's give it a quick spin. All right. I mean, I think my idea was mostly right, but I think I had some weirdness with implementation and such. Clearly. How do I feel about it? Yeah, I mean, some of it is just because n is equal to 50. We know I knew that I can do anything, right? So what is the complexity? I think that's maybe probably the first thing. And honestly, I wasn't quite sure. This is one of the few times where I didn't think about complexity because I just was worried about correctness. And with n is equal to 50, I knew I have a lot of leeway. And even if it goes to like n to the 4th, but we're still fine, right? What is n to the 4th anyway? What's 50 to the 4th? So that's why I didn't really worry about it. I was more worried about correctness. 50 to the 4th is a 6.2 mil. I guess that's actually pretty high, but yeah. So left could go to n, right? Right, it's also n. So this is of n squared, but number of inputs. But of course, we call that right or left is so input in different line. In practical terms, this is n squared. Is n squared over 2. And I put it this way. Usually I don't because big O encompasses it. But like I said, if it's n to the 4th, then all those constants add up, right? So we have to kind of at least make sure that it is fast enough. Okay, so I mean this is fine, right? But what about this? Like this is O of 1 or whatever in terms of memorization fetch. But what is this, right? I mean, this is O of n. I guess that's it, right? This is O of n. I mean, this, because all of this is O of 1, right? And so this is O of n. This is O of n log n, maybe-ish. But it's a fast n log n. So you could say this is n log n dominated by this. And yeah, so for each of these, so it's going to be n squared log n. Oh, wait, no, it's n cubed log n. Yeah, for each of the n squared input, you get an n log n, so it's going to n cubed log n, which is, fine for this one, right? So let me write it out. For each input, we do O of n log n work. So total input times work is equal to O of n cubed log n, right? And that is clearly fast enough. I mean, we got 100% times even somehow. How did I didn't C++. Is there a special way that I didn't think about? We will explore in a second, but yeah, but finishing that, basically I just kind of break them into chunks and then sort the chunks, even though I sort them incorrectly before, and it took me a little bit of time debugging. But yeah, all right. That's the complexity for time. Space is still just n squared, right? So we're pretty good on space. All right, I'm curious what I did last time. How did Smart Larry do it? Oh, so there is a greedy-ish idea. I guess this is an n cube keep on swapping if you can idea. I was actually thinking about this, but I thought, maybe I didn't think about it that much apparently. And this is yeah, I mean, and this stuff is kind of what I do with current. This is interesting. I wasn't sure. I mean, this is the greedy idea that I was thinking about initially, but I wasn't sure that it was going to be fast enough. Or no, sorry, I wasn't sure that it was going to be good enough. Rather, I guess having this, I guess it's just like way before. And this is not n cubed, by the way. I mean, this loop is n cubed, but the change makes it n to the 4th. I wasn't sure that this would be good enough. I mean, I guess n to the 4th would be good, fast. I guess if I really thought about it, it makes sense that it's good enough, but yeah, and I didn't C++. Well, technically, I think I did this in C. You could see like how everything's set up in C. Well, C with C++ strings, because it is still easier to use. But this is way early on. But yeah, I mean, the DP solution is fine. That other idea is fine too. I don't know if I have a video on that because it's just so long ago. It's one of the first things I've done. And actually, maybe I should have thought of that idea. That idea is much nicer. Or at the very least, much faster. But the DP idea is pretty interesting too. I think as soon as I saw this, maybe this part, I could have done it, but I don't know. Anyway, that's it. That's all I have for this one. Let me know what you think. This is an hour video. It's an hour of my life. So, hit the like button even if you hate it. Or if you really hate it, send it to your enemy and tell them to click on the like button because you love it so much. And then you waste their time. I don't know. That's all I have though. Thanks for watching. Stay good. Stay healthy. To good mental health. Yeah. Whew. Yeah, good mental health. Oh man, I'm so lost. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.